Okay, so today we're going to talk about translations as vectors. This is Chapter 4, Section 6. Once you finish the video, what you need to do is go to page 220, and you need to do numbers 3 through 7. And we will go over these tomorrow in class. So, we've already talked about describing a translation as a composite of reflections over parallel lines. And today in class what we did is we looked at two parallel lines. We looked at reflecting first over the first line and then over the second line. And we talked about how we would figure out the magnitude and how we would figure out the direction. So what we're going to do today is we're going to look at another type of vector. First off, a vector is something that can show you not only direction, which way to go, but also how far to go. So it shows you direction and magnitude. When we're doing a translation vector, which is what we're going to be looking at, it's a vector that's going to give the length and the direction of a particular translation. And we're going to look at these in two different ways. The first one is a vector as a ray. Now it looks like a ray, but it's not really a ray, it's a vector. It's called a translation vector. Okay, and looking at PQ, which is our translation vector right here, the initial point or the starting point of the vector is P, and the stopping point of the vector is Q. And what they want you to, what you are supposed to do is you're supposed to drag this shape A, the same direction and distance as this ray is showing. So the first thing you would have to do is you would have to measure how long this ray is. So you would have to get out your ruler or your measuring tape or whatever it is that you're going to use. So I'm measuring that, although you can't see it, and my vector is 5.5 centimeters long. So I just measured this, and I got 5.5 centimeters. So what I need to do is I need to start down here on my A of my triangle, and I need to measure a distance that's the same 5.5 centimeters, but I need my ray to be parallel to this original ray that's showing right here. So I need to make sure that the direction of the ray is the same, and to make sure the direction is the same, I would use a parallel vector. And then I would measure this out, and I might even move it one point at a time. I'd move point A, the distance and direction I need to, move point B, the distance and direction I need to, and move point C. Now, if you go to this website down here, the Math is One Fun website, there is a translations activity that you can try on this website. There's a vector one, and then there's also a different type, which we're going to talk about next. Okay, now this one is translating on the coordinate plane. Of course, the coordinate plane makes it much easier because we can quantify our direction and distance. This, although it looks like a coordinate, in this case we're actually using it as a vector. And what this vector is telling me, it's telling me that I need to move 5 on the x-axis in the positive direction and 1 on the y-axis in the negative direction. So I would take my pentagon, I would move it 1, 2, 3, 4, 5 in the positive direction in the x, and then 1 in the negative direction on the y. And this is just another way of showing a vector. I could do some other different vectors, like maybe I would want to do a vector of, let's say 2 on the x and 5 on the y. So let's look at how we would do that one. So I would start out with my original pentagon again. I would move it 1, 2 on the x, and then I'd move it 1, 2, 3, 4, 5 on the y. So this just tells me how far to move it on the x and how far to move it on the y. Here's a little activity you can try if you want to. You would draw a vector, which this is vector DE, And after you draw vector DE, you would have this triangle here, ABCD. So the first thing you would do is you would connect these two. You would have to measure the angle and measure this other angle so that you could get a parallel line. So that's what we're doing here, is we're trying to get a parallel line. Then after we get the parallel line, we just measure how far to move it, and we would move first point E that far, or B that far, and make it B prime, and then we do the same thing with A and C. Now, we probably will not have to, on a test or a quiz, move something like this by hand, but it's nice to know that it can be done, that I can slide it by measuring the angle and figuring it out. Okay, so now that you've listened to the video, I want you to go to page 220 and do problems 3 through 7.